31. List all potential rational zeros. Before we do this, let's recall the rational. Recall what? The rational zeros theorem. What does it say? You have p of x. It's an x to the power of n. Go down to the a1 x1 plus a naught, right? And all the coefficients are integers. All coefficients, all ans, right? Coefficients are integers. Okay? Then, let me write there, here. Consider the rational, consider a rational number p over q. What is p? P and q are relatively prime. What does this mean? P and q, when you divide them, there is no common factor, just the one, okay? So P and Q are relatively prime means they have no common factor, just -1 and 1 only. So if P over Q is a 0 of P of x, then P is a factor of a naught and Q is a factor of an. Let's go back and apply this to the problem. So let's look at the an and a naught. Where is a naught? A naught is positive 19. This is a naught. A naught is p. We call it p, which is 19. What is an? An in this case a5, because 5 is the highest degree, so we call it a5. A5 is a q, which is 1. Now, what are the possibilities of having rational zeros? Having rational zeros, what we have to do is look at the p, and look at the q, and look at the factors of p and factors of q. What are the factors of p? P, we have 19. What are the factors of the p? Either 1, positive or negative, or 19, positive or negative. And what are the factors of a q? The factors of a q. Only 1, positive and negative. Okay? When you study all of these cases, what do you get? The first case, if you divide 1 over 1, is going to be 1, positive. What if you divide -1 over +1? It's going to be negative. Or +1 over -1 is going to be negative. So we have two cases here, positive or -1. The other case, when you divide 19, if you divide 19 over 1, what do you get? Either positive 19 or negative 19. So only we have two cases. These two or four numbers, these are four numbers, are the candidates to be the rational zeros of this polynomial. Okay, so we have only four candidates: 1, positive, -1, 19 and -19. These are the rational candidates. What about other candidates like complex numbers? We don't know. What we know is, we don't know about them, but we know that we are going to have these candidates as a rational numbers. Complex numbers, we don't know them, okay? So the answer is going to be